Based on popular demand, in this video we'll be solving JAMB past questions for year 2017 as part of a series on the JAMB 2023 preparations. Alright, let's start. The first question says, the flame used by welders in cutting metals is A. butane flame, B. acetylene flame, C. kerosene flame, and D. oxyacetylene flame. The correct answer here is oxyacetylene flame. Now, I'll explain why it is oxyacetylene flame. Oxyacetylene flame is a mixture of oxygen and acetylene. And acetylene is also called what? Ethine. That's C2H2. Now, ethine is an alkyne, which is a hydrocarbon, because it contains only carbon and hydrogen. And alkynes, the first member starts with what? A double bond, because they have a functional group, which is what? Carbon, carbon, what? Triple bond. Now, alkynes, being hydrocarbons, bond in oxygen. They bond in oxygen to produce carbon dioxide and and steam or water, as the case may be. Now, the heat evolved in these reactions, which is always an exothermic reaction, because the combustion reaction is always used as a source of what? Energy, right? So now, for ethine bonds in oxygen with a sooty blue flame due to its high carbon content to evolve a large amount of heat, which is used in the welding process for cutting what? Metals, as specified or as stated in this question. Now, the temperature is always as high as 3000 degrees what? Celsius. The temperature of the flame evolving during this reaction is as high as 3000 degrees what? Celsius, and which is far higher than the melting point of most what? Metals, which is why it is used for cutting metals. Now, what you should also notice is that apart from the oxyacetylene flame, another flame that is also used, that can also be used for cutting metals, is the oxyhydrogen flame. The oxyhydrogen what? Flame. And just like the name, it is made up of what? It's a mixture of what? Oxygen and hydrogen. Yes, of course, as shown in this equation for the formation of what? Water. But the difference is that the heat evolved in the oxyhydrogen flame, or the combustion of hydrogen, is not as high as the heat evolved when ethine bonds in oxygen. That's why the oxyacetylene flame is a better flame for welding metals or cutting metals than the oxyhydrogen what? Flame. But the oxyhydrogen flame can also be used as a substitute for the oxyacetylene what? Flame, in case the oxyacetylene flame is not available. So that's why the answer to that question is D, oxyacetylene flame. In question 2, you are told that at room temperature, that's about 300 Kelvin, in the figure below, A, Y is twice as soluble as X, B, X is twice as soluble as Y, C, X and Y are soluble to the same extent, D, X is 3 times as soluble as Y. Now, if you look at the solubility curve, why is it called a solubility curve? It's a solubility curve because it's a graph of the solubility of substances measured against what? Temperature. That's a solubility curve. Now, if you look at the solubility curve, you have two substances here, X and substance what? Y. At 0 degrees Celsius, which is 273 Kelvin, Y is more soluble than X, as you can see from this plot. But as the temperature increases, there's a variation in their solubility. It means that the solubility of solids is dependent on what? Temperature. Because you can see from these plots that the solubilities of both X and Y vary with what? Temperature. So at 300 Kelvin, what will be the solubilities of X and Y? Now, if you look at this scale, the X-axis scale, that is the temperature scale, The first value here is 273 Kelvin. The next value is 283 Kelvin, which means that 2 centimeters represent 10 Kelvin, right? So 283 Kelvin, the next one is 393 Kelvin, while this one here is 303 Kelvin. That's this point is 303 Kelvin. So it means that 300 Kelvin will fall to the left of 303 Kelvin. So let's look at this. We'll not be able to get the exact value, right? But let's just see. We have 5 smaller divisions here, and these 5 smaller divisions give us 10 Kelvin. So like each division will be what? 2 Kelvin. So we have, if this is 293, 295, the next one will be 295, that one will be 297, that will be 299, right? That one will be 301. So which there are 3 Kelvin, 200 Kelvin will be somewhere here. And we trace this down here, we trace it up to this point. This is where it will meet this first curve, right? Let me use another color so you can easily differentiate it. Let me use blue. So if we trace it down here, and let's say that's at 300. So we trace it to the solubility curve. That gives us 20 grams per 100 gram of water. Well, this one now, if we now continue extending forward to this other substance, that gives us what? 40 grams to 100 grams of what? Water. So what do these values mean? Which substance is this? This is our X. Well, this is our what? Y, right? So you have to be very, very careful when answering questions like this. Remember, when we started, X was lower than what? Y, right? Yes, X was lower than Y. And when it is ending here, Y is lower than what? X. So if you are told to trace or to extract the solubility of a substance from a curve, you don't just pick any value, assume that, okay, since X was lower or is lower than Y at the beginning, X will always be lower than Y till at the end. Does not really matter. It doesn't follow that way, right? So at this point, at this temperature, the solubility of X is still lower than the solubility of what? Y, right? Because from what we are seeing here, for 100 grams of water, 20 grams of X will dissolve completely in 100 grams of what? Water. Whereas for the same volume of water or mass of water, 40 grams of Y will dissolve in it. So you can see that the solubility of Y here, there will be more Y in solution than what? X. Or there will be more Y in the same volume of water than X at what? Room temperature of 300 Kelvin. Now, what is the variance here? While X is 20, Y is what? 40. So it means that the solubility of Y is twice the solubility of what? X. So it means that our answer to this question is what? A. Y is twice as soluble as X. So let's move to the next question. Question 3. Tetrasulfate 6 acid is prepared using the chemical reaction SO3 gas plus H2O, that should be liquid, giving us H2SO4 liquid. Given the heat of formation for SO3 gas, water, and H2SO4 liquid as minus 395 kilojoules per mole, minus 286 kilojoules per mole, and minus 811 kilojoules per mole respectively, the enthalpy change accompanying this reaction is as shown on the screen. This question is on energy in chemical reactions, or what we call energetics, right? So in this question, we are asked to calculate or determine the enthalpy change of the reaction for the formation of H2SO4, right? Or for the preparation of H2SO4 from SO3 and water. Now, the enthalpy change of a reaction is calculated as delta H reaction, that's enthalpy change reaction, as the summation of the enthalpy of formation of the product minus enthalpy, summation of the enthalpy of formation of the reactant. right? Now in this question, what are the reactants? The reactants are this: SO3 and water are the reactants, while H2SO4 is the product. So if we substitute the values or the formulas of the compounds into the equation, we'll have enthalpy of formation of H2SO4 minus the enthalpy of formation of SO3 plus the enthalpy of formation of water, since H2SO4 is the only product and we have two reactants here. So if we substitute these values, the values of the heat of formation, into the equation. Meanwhile, what's heat of formation? Heat of formation is the amount of heat evolved or absorbed when one mole of a compound is formed from its constituent element at standard state, right? So substituting these values, the heat of formation of H2SO4 is minus 811, that's minus 811, minus bracket opens heat of formation of SO3, so for 6-oxide is minus 395. Please, when answering questions like this, you have to be very, very careful of the signs. Now plus into minus heat of formation of water, which is minus 286, all in kilojoules per mole. So if we evaluate this, we get minus 811 minus into what? Minus. Plus times minus is minus. So that will give minus 395 minus 286. That will give us what? Minus 681, right? And further evaluation of this becomes minus 811 plus 681, which gives us minus 130 kilojoules per mole. So the answer to this question is B, minus 130 kilojoules per mole. Remember, when you are answering JAMB questions, you have to be fast because JAMB tests your speed and accuracy. I'm only taking time to explain this so that you can understand the concept. When you are solving, you don't need to go through all these rudiments, right? Because it will waste your time. So let's move on to the next question. Question 4. In two separate experiments, 0.36 grams and 0.71 grams of chlorine combined with a metal X to give Y and Z. An analysis showed that Y and Z contain 0.20 grams and 0.40 grams of X respectively. The data above represents the law of A, multiple proportion, B, conservation of mass, C, constant composition, D, reciprocal proportion. This question is on the laws of chemical combination, right? We are told that 0.36 grams and 0.71 grams of chlorine combined with a metal X to give Y and Z, right? Now, on analyzing Y and Z, analysis shows that Y contain what? 0.20 grams of X and Z contained 0.40 grams of what? X. Fine. So we want to determine which law this data represents, right? Okay, let's see. So we have samples. We have chlorine. We have metal. And we have total mass. So for sample Y and sample what? Z. What's the mass of chlorine for sample Y? 0.36 and 0.71. Okay. For sample Y, X is 0.20 and Y is 0.40, all in grams. Now, what's the mass of sample Y? Sample Y is 0.36 0.56 grams, while sample X is 1.11 grams. Okay, let's see. Now, I'm suspecting that it will be the law of definite proportion, since the masses of both chlorine and the metal vary in both sample, right? Had it been that the mass of chlorine was fixed or the mass of the metal was fixed and the masses of chlorine varied, right? Then it could have been the law of multiple proportion. Okay, so since these masses vary, what's the percentage of chlorine in A? Percentage by mass of chlorine in Y. That will be what? 0.36 divided by 0.56 times 100 over 1. If the percentage of chlorine or any of the elements in both samples Y and Z are the same, then it will be law of definite proportions. That's 64.28, that says 29%, approximately 65%. Okay, let's look at the percentage of chlorine in Z. If it is the same as that of Y, then it is the law of definite proportion. But if it varies, then it would be the law of multiple proportion. So this will be 0.71 over 1.11 times 100 over 1, which gives us 63.96%. Actually, this is approximately 64%, while this one's, that's my bad, this is actually approximately 64%. So since we have approximately the same percentage of chlorine in both samples, then is the law of definite proportion, which is, for our law of definite proportion is not here, but law of definite proportion is also known as the law of constant composition. So the answer is C. And what does it state? It states that all pure samples of a chemical compound contain the same elements combined in a fixed ratio by mass. So that's what we have just illustrated here. That's this. You can see 64% chlorine. So from here, percentage composition of the metal in both samples will be 100 minus 64, which will be that's 36%. So that's also our last question for today. If you are getting any value from this tutorial, kindly hit the like button, and if it's your first time here, subscribe to our channel, right, to stay updated with our new uploads, where we'll be solving other questions, maybe from question 6 to question 10 in the second part of this series. Our last question for the first part of this series. Question 5. If an element X of atomic number Z and mass number Y is irradiated by an intense concentration of neutrons, the relevant nuclear equation is as shown on the screen. So which of these will be the correct answer? This question is on radioactivity, and it is more of an artificial transmutation where a radioactive nucleus is bombarded with a neutron. Now, to know the correct nuclear equation, we use the mass numbers and the atomic numbers to balance our equations. In other words, we don't balance atoms like chemical equations, because in nuclear reactions, atoms are destroyed and new atoms are formed, right? Unlike chemical reactions where atoms are neither created nor destroyed, but can be changed from one form to another according to Dalton's atomic theory, right? One of the postulates of Dalton's atomic theory. Now, that postulate was flawed with the advent of radioactivity, right? The discovery of radioactivity. So in this case, what is going to happen? We are told that X has an atomic number Z and mass number Y, right? And when we bombard it with a neutron, what will this give us? If we add the atomic numbers or the mass numbers of X and N and the neutron, what will we get? This will be what? y plus 1, right? And if we add the atomic numbers of Z and the charge of the neutron, which is 0, right? What will we get? We get what? 0. That's Z plus 0. Still what? X. Since the atomic number does not change, it still gives us what? X. So if we evaluate this further, this will give us what? Y plus 1. The mass of X will now be what? Y plus 1, while the atomic number of X will still remain as what? Z. So what's the answer to the question? That will be option B. So option B is the correct answer. So that brings us to the end of the first part of a series for the 2023 JAMB preparation. Learned anything from this tutorial? Endeavor to leave a comment and hit the like button, and also don't forget to subscribe because there are still many things to learn in a subsequent series. Always strive to be a better version of yourself until I see you when I'll see you.